All right, last time we left off with solving linear equations. We had seen some pretty complicated examples. However, now let's take a look at what happens when we have to deal with fractions or decimals. Most students are pretty intimidated by them, so let's just go through a few things that we're going to need to know really quick. Let's start with how to multiply fractions. Like I said, 2/3 times 4/5. Remember, to multiply fractions, all you have to do is multiply straight across. So that gives me 8/15. However, let's take a look at another one, say 2/3 times, 5/4. We could just go ahead and multiply straight across, and notice we would get 10/12. Or we could reduce first. You can reduce any factors on the top with any factors on the bottom. And notice the 2 goes into 2 once, goes into 4 twice. Now if we multiply straight across, 1 times 5 is 5, 2 times 3 is 6. And notice that's, of course, what this would reduce to. Anytime we're reducing here, or anytime you're multiplying, you want to try to reduce your fractions first. Now, the one more thing that we're actually going to need is, let's go through this really quick before we get there. Converting decimals to fractions. We're actually not going to want to work with decimals. We're actually going to want to work with fractions. I know a lot of you don't like fractions, but the rules for fractions are actually a little bit easier than decimals. So let's see if I gave you 0.7. Well, if you read this, this is 7/10 or 7/10. So if I said 0.23, again, if you read that, that's 23/100. Or let's make it hard, 5.27. This is a little bit difficult. A lot of students say, well, I can write that as a mixed number, 5 and 27/100, right? 5 and 27/100. That's fine. You can do that if you want, but it adds an extra step in there. And we really don't want to work with mixed numbers either. Think about how we did it for these two. How did we get the number on the bottom? Well, the number on the bottom was the decimal place farthest to the right here we had the tenths place and the hundredths place, and of course we had a 10 and a 100. And then how did we get the number on the top? Well, we basically just wrote this without a decimal place. So if I take this, write that without a decimal place, I get 527, and the decimal place farthest to the right is 100. So that's all you got to do. Anytime you want to change a decimal to a fraction, so if I had 63.123, write the number without a decimal, so 63.123 all over. Let's see, this is the farthest place to the right is the tenths, hundred, thousandths place, so that will be 1,000. All right, so converting from decimals to fractions is pretty straightforward. All right, we're going to be using that in just a second. So let's go on through and take a look at solving linear equations again. Let's back it up and make it a little bit easier than the last one we saw. Let's say 2/3 x plus 1/4 is equal to 5/6. All right, just like we did last time, before you do anything, you always want to classify what type of equation this is. It's an equation, of course, because it has an equal sign. It's linear because all of our x's are raised to the first power. So, following our steps. Step 1, clear grouping symbols. You always have to clear those first before you try step 2. Step 2 says clear fractions or decimals. So to clear our fractions here, what you're going to do is you're going to multiply every term by the least common denominator. Remember, the least common denominator is the smallest number that is divisible by all these denominators. So the smallest number that is divisible by 3, 4, and 6 would be 12. All right, the best way to write this, as you can see in our original equation, we have 3 terms up here. So put the 12 out in front of each one of your terms and put your terms in parentheses. 12 times 5, 6. Now the reason this works, let's go over to the side and do some arithmetic real quick. We have 12 times 2/3 is our first one. Now remember, you can always write a whole number as a fraction by putting it over 1. Now we could go ahead and just multiply straight across the top and straight across the bottom, but we do want to simplify first when we're multiplying. Now the reason that this works so well is since this is the least common denominator, by definition this has to go into it evenly, which means we can go 3 goes into 3 once, goes into 12 4 times. Now notice on the bottom we have a 1 times 1, or just a 1, which we don't need to write. And on the top we have a 4 times 2, which is 8. So you see that's going to get rid of our fractions. Now here's the best way to write it when you're doing this. Let's just kind of walk through here. 3 goes into 12 4 times. 4 times 2 is 8. Those are x's. Plus 4 goes into 12 3 times. 3 times 1 is 3. 6 goes into 12 twice. 2 times 5 is 10. So you can see in one nice easy step, we don't have any more fractions, so we can go back to just following our steps. Move all your x's to one side, that's done. Move everything that doesn't have an x to the other side, so let's get rid of that 3. So we have 8x is equal to 7. Last step, divide both sides by whatever's in front of our variable. We get x is equal to 7/8. Okay, so just following your steps, if you do see fractions or decimals, to make your life a little bit easier, you can add one more step in there by multiplying through by the least common denominator, and that will get rid of all your fractions. Now, decimals work almost exactly the same. It's just we ended up with one extra step. So let's take a look at some decimals here. Let's see, 0.2 times, 1.3x plus 4 is equal to, 0.16. All right, so again, before you would do anything, you'd classify this and say, hey, that thing right there is a linear equation. The reason we do that is because now we know that these steps over here will solve the problem for us. Step 1 says clear grouping symbols, which you could do here. There's actually nothing wrong with that at all. However, a few moments ago, I told you we didn't really want to work with decimals. So go ahead and rewrite these decimals as fractions before you even start the problem. That'll be 13/10 of x plus 4 is equal to 16/100. All right, now as you can see, at least two of these fractions we could reduce at this stage. It's kind of up to you if you want to. There's drawbacks to each way, whether you do or you don't. Well, let's go ahead and distribute here. So if we distribute the 2/10, remember you just multiply fractions straight across. So 2 times 13 would be 26. 10 times 10 is 100, those are x's, plus, remember that's a 4 over 1, so 2 times 4 is 8 tenths is equal to 16/100. Now, since I didn't reduce my fractions, that means when you're dealing with decimals, your least common denominator will always be a power of 10, either 10, 100, 1,000, something like that. And you can see here that our least common denominator is 100. So I'm going to multiply every term, whether it's a fraction or not, by my least common denominator. So of course 100 goes into 100 once, so this is just 26x, plus 10 goes into 100 10 times, which is 80. 100 goes into 100 once, times 1 is 16. All right, again, it makes it a much easier equation to solve. Next step says move all your variables to one side. All the x's are already on the left. Move everything that doesn't have an x to the right, so we get 26x is equal to 70/64. Last step, divide both sides by whatever's in front of our variable. Divide both sides by 26, and we get x is equal to. All right, now we know our answer is going to be negative because a negative divided by a positive is a negative. That'll reduce. 2 will go into both of those. It gives me 32/13. All right, there you go. Now here's a slight drawback to switching to fractions, even though this is easier to do. A lot of textbooks kind of use the rule is if your problem started with fractions and your answer should be fractions or whole numbers. And if you start with decimals, your answer should be decimals or whole numbers. So if you looked in the back of the book on this one and you have a fraction, the book has a decimal, you might be a little bit confused there. Now remember, to get from a fraction to a decimal, all you'd actually have to do is actually do the division. You'd have to do 32 divided by 13. Now that would be an absolute horrible number because I just made these up off the top of my head, but most of the time it'll be pretty easy for you to do. All right, so clearing fractions or decimals, same basic idea. Find the least common denominator for all the fractions and multiply through by. Now remember, our directions here are still just solve, just like from the first part. Let's take a look at something else that can happen when we're solving these. Let's say we got So looking at this mess, again, our directions are just solving. First step is always saying what type of equation this is. This is a linear equation. Okay, so how to solve a linear equation? Well, our steps right there will work. Step 1 says clear the grouping symbols by distributing. So if I distribute to 2, I'm going to get 6x plus 12. Here I have parentheses. Now what do I distribute here? Well, remember, if you don't see something, there's an understood 1 there, so we just distribute that 1, so that just gives me x minus 3. All right, step 2 says clear fractions or decimals. We don't have any in this one, so we can keep going. Move all your variables to one side. Now, before we do that, remember our red step down there at the bottom, we always want to combine any like terms if we can, or simplify. I can't simplify the left, but I can simplify the right. All right, so step 3, move all your variables to one side. So let's say we wanted to move all our x's to the left, like we normally do. You'd say, okay, I'd subtract them from this side, and I'd subtract them from this side. And here's where a lot of students get confused, like, oh, what happens? Well, just write down what happens. Don't guess, just say, okay, well, that goes away, and I end up with 12, and that goes away, and I end up with negative 3. Now, here's a problem with this problem. Notice we don't have any more x's, so this can't tell us anything about the value of what x has to be. We have to get some more vocabulary in here to kind of help us. Well, vocabulary that we already learned the other day. All right, here's the idea. Remember what it means to be a solution. It's the value or values that when you plug it into the original gives you a true statement. So here's kind of how this would work. Let's say we thought x equals 3 was a solution. Well, if we plugged it into here, guess what we would get? We'd get something like this, 12 equals negative 3. That's false, which means x equals 3 is not a solution. What if we thought x equals 7 was a solution? Well, if we plugged it in, we'd end up with something like this, which again is false, which means that can't be a solution either. In fact, it doesn't matter what we plug in here because this is always false. Since this is always false, there can't be any solution, so we would say that there's no solution here. Now I'm going to change this just a little bit just to save us a little bit of time. What if, just say what if, that would have been 12 equals 12. What would that have told us? Well, if we try to do the same thing, we say, okay, is x equals 3 a solution? If we plugged it in, we'd end up with something like this, which is true. That means 3 is a solution. Or if we tried to plug in 7, we'd end up with something like this, which is true, which means 7 is a solution. In fact, anything we plug into this is always going to give us a true statement, so every number works. And if that was true, we would say that our answer would be all the numbers are all real numbers. Now, I'm putting this back the way that it was. And let me give you a very important sentence for us to remember. All right. When you're solving equations and all the variables, let's just say go away or cancel out, only two things can happen. Okay, now what do I mean by this? Remember, an equation is anything with an equal sign. So we got something that looks like this. If all the variables go away, that means we only have numbers and an equal sign. And two numbers are either equal to each other or they are not equal to each other. So what you're going to end up with is either a true statement or a false statement. That's the only thing that can happen. Now, depending on which one of these you get is how you answer the question. Now, we saw a false statement was no solution, and our true statement, we said all the numbers work, so we're going to say all real numbers. Now, a lot of times here you'll see symbols used for these, and you're welcome to use them if you want. The symbol we use for all real numbers is a capital, bold, scripty R looking thing. But since we can't write bold when we're using pen or pencil, the way you write a bold letter is you add an extra line in it somewhere, and we add it on the down part of the R. That means all real numbers. For no solution, you generally see a small circle with a line through it. That means that's a symbol for what's called the empty set or the null set. Basically, it's a group of nothing or no things in it whatsoever. All right, now here's the good news here. Notice this says when solving equations, not when solving linear equations. This is true for any type of equation you solve from now until the end of time. If all the variables go away and you get a false statement, the answer is always going to be no solution. However, if you do get a true statement, we do modify this a little bit in the future to kind of fit the problems that we're talking about, but the idea is the same here, is you end up with an infinite number of solutions. In this case, it's all the real numbers. All right, solving linear equations is a very important skill that we're going to need for the rest of our math career. So make sure every time you go to solve one of these problems, you're classifying it, saying what type of equation it is, and read through these steps every single time. It'll help you memorize it, and you'll find out that you do a much better job at getting the right answer.